Alright guys, let's get started with concept 51. Please write concept 51 for the topic. Okay, I am not going to accept papers in the future that do not have this written. So in the previous one we refreshed ourselves with the 3 basic trig ratios, and then we learned the 3 identities as well. Part of this concept here is we're going to use it to, well, this first section here, we're going to use that to be able to find side links. So this may or may not be new, depending on what was covered last year. So I'm given an angle 64 degrees, okay, and I want to find this x here, and I have the hypotenuse given, right, because it's across my right angle. So I need to think, what trig ratio is going to help me to find what x is? So sine of 64, SOHCAHTOA, right? So maybe it helps to have it written in, okay? Opposite of the angle over the hypotenuse, okay? So sine of 64 is equal to opposite over hypotenuse, okay? So then I can multiply, like an equation, right? You multiply both sides by 25, so I get 25 times sine of 64 degrees is equal to x. And then you just put this in your calculator, and then that gives you the answer. Now, one thing you have to do though is in your calculator just hit mode, okay, and then switch. It might be on radians, switch to degrees, okay, because what you're telling the calculator here is that when you're inputting that trig function, you're inputting a degree measure. So sine of 64 times 25, and you get 22.469. So you could just round to 24 point, because we're finding side measures, this one can just be like rounded to 22.5, and you're good. Next one, so it's a right triangle flipped on its hypotenuse here, but I'm given 47 degrees. The hypotenuse is not given, okay? So I'm not going to use sine, and I'm not going to use cosine, so I have to use tangent. So tangent of 47, opposite over adjacent. So tangent of 47 degrees is equal to opposite over adjacent, x over 12, and then this would be equal to 12 times tangent 47 is equal to x. So put that in your calculator, and you're gonna get 12 point, if we round, you're gonna get about 12.9. Okay. Number 3, I have 18 degrees. I need to think, okay, I need to find this guy, the adjacent angle. Hypotenuse is given, so cosine of 18 degrees, right, opposite over hypotenuse, is adjacent over hypotenuse is x over 34. Then 34 times cosine of 18, that gives me x. Put that in your calculator, and you get 32.3. Number 4, I have an adjacent angle and an opposite angle to 35, so I'm actually going to be using tangent in this case. No hypotenuse is given, so no sine, no cosine. So tangent of 35 is equal to 9 over x, and this one would be a little different in a sense, right? Because I need to find this guy, the denominator. I would multiply both sides by x, so that gives me x times tangent 35 is equal to 9, and then I could divide by tangent 35, so I could get x is equal to 9 over tangent 35, and then put that in your calculator. You're gonna get 12.85, so x is equal to 12.9. Number 5, hypotenuse is what I'm looking for. I have an angle of 63 degrees. Opposite side of that angle is given. So sine of 63 is equal to 27 over x. And x, I'm going to skip a step, right? It's similar to number 4. I would get x sine 63, and then I would divide. So I have x is equal to 27 over sine 63. And then in your calculator, you're going to get 30.3. Last one here, I have a 30-degree angle, adjacent side is given, hypotenuse I need to find. So I'm using cosine because adjacent side is given. So cosine of 30 is equal to 18 over x. And then similar to 5 and 4, I'm going to get x is equal to 18 over cosine of 30. And that gives me 20.8. So next section, if you know the sine, cosine, and tangent ratio of an angle, you can use the inverse of the ratio, sine, and it looks like sine to the little -1, cosine -1, tangent -1. It's just read as sine inverse, cosine inverse, tangent inverse to find the measure of the angle. So sine theta is equal to x, so then the inverse would be that theta is equal to sine inverse of x. Similarly, theta is equal to cosine inverse of x. And then finally, theta is equal to tangent inverse of x. In the previous section, we used our trig functions to find sides. The inverse functions help us find the angles given the sides. So here's this missing theta. I have the opposite side, I have the adjacent side, so I know this is tangent of some angle is equal to 8 over 14. So what would be that angle? So I can take the inverse tangent, so theta is equal to tangent inverse of 8 over 14. Okay, and then put that in your calculator, and your mode stays the same. You want to have it in degrees because your answer is in degrees. So tangent, and how do you hit the inverse function? They're located right above the actual trig function. So hit second, and then tangent, so it's going to look like this, and then put 8 over 14, and you're going to get 29 point, so theta is equal to 29.7, yeah, 29.7, you can just round to the nearest tenth there, 29.7 degrees. Okay, don't forget your little degree symbol. Next one, I have the hypotenuse is given, the adjacent side to theta is given, so it's cosine, so I have cosine theta is equal to 38 over 40, so then theta is equal to cosine inverse of 38 over 40. Put that in your calculator, you're going to get 18.2. So theta is equal to 18.2 degrees. Number 9, theta is given, opposite side to theta is given, and my hypotenuse is given, so this is sine. Sine of theta is equal to 17 over 22. So then sine, theta is equal to sine inverse of 17 over 22. I put that in your calculator. You're going to get let's see, 50.6. So theta is equal to 50.6 degrees. Last one here, I have the hypotenuse is given, and then I have an adjacent side also given. So it's cosine. So cosine theta is equal to 11 over 48. So then theta is equal to cosine inverse of 11 over 48. And you're going to get theta is equal to 76.8 degrees. Okay, so that's how you find angles given side ratios. The next little section here, we have angle of elevation. So they're basically word problems with some context. They're gonna give you all sorts, like you're either going to be finding the theta, the angle of elevation, or you might be finding a side length or whatever, or a height, whatever it is. And this little diagram here explains it pretty well what an angle of elevation is. Generally you have an observer, and then whatever the observer, or I don't want to say just the observer, because you might have an observer up here or something, but anyway, the angle of elevation is just kind of like made by that line of sight. So number 11 says the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. So helps to draw out that triangle. Whoops, that was sloppy. Okay, so I have this triangle here, and it told me that the angle of elevation is 5 degrees. So I could just label that 5 degrees there. The top of the lighthouse is 161 feet. So again, don't mind my diagram, it was pretty bad. So 161 is how tall it is, and above sea level, how far is the boat from the lighthouse? So then I'm finding this side here, right? The boat is here, line of sight, angle of elevation, lighthouse is here. So it's let me see, I have opposite and I have adjacent, so this is tangent. So tangent of 5 degrees is equal to 161 over x, and then if I solve for x, I get that x is equal to 161 over tangent of 5 degrees. And then when you put this in your calculator, you should get a big number, because tangent of 5 is pretty small. You're gonna get x is equal to 1840 point, we'll just round, so 0.2 feet. And don't forget your unit of measurement. Number 12 says the angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. So there's my triangle. This guy is now 44 degrees. And I apologize for earlier if I confused you guys on explaining the diagram. Actually, I was thinking of angle of depression already. So anyway, moving on. I have 44 degrees, and then it says if the top of the slide is 16 feet above ground, so this is 16 feet, find the length of the slide. So the slide would be this here. So I have opposite, and of course I would have hypotenuse. So this is sine. So sine of 44 degrees is equal to 16 over x, and then solve for x, I get that x would be 16 over sine 44, and then that would give me 23. Yeah, 23.03. So you could just round to 23. So 23 feet. It's a pretty long slide. Number 13 says a 10-foot ramp is used to unload furniture from a truck. So I have this here. If the back of the truck sits 3 feet above ground, find the measure of the angle and the ramp makes with the ground. So I'm finding that angle of elevation. So this is not given. I know the ramp is 10 feet long. Whoops, sorry guys, I didn't realize I was out of view there. And then the ramp says 3 feet above ground level. So theta, opposite is given, hypotenuse is given, so this is sine. Sine of theta is equal to 3 over 10. And then I would have to take the inverse sine because theta is not given. So theta is equal to sine inverse of 3 over 10. And then that's going to give you about 17. Theta is equal to 17.5 degrees. Okay. Angle of depression is, this is the one I was thinking of earlier. So it's like when you have a viewpoint from above to something looking down. So the line of sight is downward, and then the angle of depression is shaped by, well, like the horizontal line from the view, from the perspective to the line of sight looking down. So works the same way, except my triangle again is generally flipped this way, right? So you have this triangle here. So 14 says a fire is spotted from the top of a 125 foot tall fire tower. So let's see, if I draw my triangle, I keep drawing these so sloppy, I apologize guys. So I would have something like this. So a fire is spotted from the top of a 125 foot tall fire tower. So it's like my tower would be here, right? My line of sight would be here, my fire is down here. This height is of course the same as the one here, so I have 125 feet. If the angle of depression of the fire is 19 degrees, so this angle here is 19 degrees, how far is the fire from the base of the tower? So again, my tower, right, my tower, so if I were to like just draw a tower, here's my tower, my fire is right there, so they're trying to find how far is it from here, and then this bottom length is of course the same as that top length. Okay, so opposite is given, adjacent is also given, so this is tangent. So tangent of 19 degrees is equal to 125 over x, not given, and then I solve for x, and I get x is equal to 125 over tangent of 19. You're gonna get, let's see, I'm getting x is equal to 300, and if I round, 363 feet. So the fire is 363 feet away from the base of the tower. Number 15 says an airplane is flying at an altitude of 8,900 feet over water. So there's my triangle. It is 8,900 feet above water. The pilot spots a raft floating in the water at a 28-degree angle of depression. So 28. So I guess the plane would be here. The plane would be here, and then it spots the raft over here. And again, it's 8,900 feet above water. So what is the horizontal distance from the airplane to the raft? Well, the horizontal distance would be this here, right, to the plane, which is here, which is also the height up here. So x. Opposite is given, adjacent is what we need to find, so this is tangent again. So tangent of 28 is equal to 8,900 over x. X is equal to 8,900 over tangent of 28, and then if I put that in my calculator, you're gonna get let me see, So, whoops, sorry, mistyped the number here. I get tangent 28, so I'm getting this huge number here, 16738 0.5. so that would be how far the horizontal distance is. Last one says Max is sitting in the stands at a baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet. So this dude is sitting 61 feet. The horizontal distance is 61 feet from the player. There you go, right there. The ball travels 76 feet. What is the angle of depression from Max to the player? So, I mean, nobody, whoops, that's theta. Nobody would be able to throw it like super straight, super straight to a player, right? But it would generally arc. But for the sake of this problem, right, it travels 76 feet, and then it says what is the angle of depression. So we're finding theta. So adjacent to the side adjacent to theta is given, hypotenuse is given, so this is cosine. So cosine of theta would be 61 over 76. So then theta is equal to cosine inverse of 61 over 76. And then this gives you, this would give you 36.6 degrees. So theta, 6.6 degrees. And that's it. This wraps up concept 51.